Hey, darn it, I thought we were going to get all the way through in 15 minutes, but I promise we'll go fast here. Okay, so we were saying that we are just going to take the square root of our numerator and our denominator. So the square root of 81 is 9. So we would say 8/9 and negative 8/9 would be our solutions. We can check those by substituting them back in. If I put 8/9 in for A and then I square it, 8 times 8 would get me back to 64. 9 times 9 would get me back to 81. So we will go ahead and let you take a turn checking this one out. You can pause the video and solve this. I believe this will also be one of your quick check questions. And then let's look at a real life example. So a company makes small custom designed stamps that have a square image area. The image area has an area of 1,200 millimeters squared. What is the exact length of one side of the image area? If your answer is not a perfect square, approximate your answer to the nearest tenth of a millimeter. So let's check out what we have. We know that the length of it's a square, so all the lengths are the same. And we also know that the millimeters they're measuring in are millimeters squared. So we know that the area equals 1,200 millimeters squared. Well, if I want to know the length, I know that the area of a square is side squared or length times length. So if that's the case, and I want to find what the side length equals, I can take the square root of each side of the equation. And I'm remembering that when I take the square root of 1,200, I need to consider the positive and negative versions. So when I need to know the exact length of one side of the image area, I would say that the exact length would be the square root of 1,200. Because when I actually punch that in on my calculator, I find that I'm going to get an approximate decimal because 1,200 is not a perfect square. So when I take the square root, I'm going to get an irrational number, a non-repeating, non-terminating decimal. I also know that since I'm talking about side length, I can rule out the negative version of this because I'm not going to have a negative side length. So on my calculator, when I type in the square root of 1,200, I get 34.64. So if I'm going to round to the nearest tenth, I can just leave that as 34.6 millimeters, or 34 and 6/10. All right, I am going to leave this question to you. And now we are going to begin talking about cube roots. So cube roots and cubes are very similar to perfect squares and square roots, except now we are talking about a number that is a cube of an integer is a perfect cube. And so when we're saying 2 cubed, you might be literally picturing a cube in your mind, which is a great way to think about it because just as a cube is three-dimensional, when we say 2 cubed, we mean 2 is our base and our exponent is 3, or 2 to the third power. So this literally means that 2 is a factor 3 times. So 2 times 2 times 2. As you're first getting started with these, break them down and do it one at a time. 2 times 2 is 4, and then 4 times 2 is 8. So be careful that you don't fall into the trap of adding these. 2 cubed is not 6. So take it one at a time. 2 times 2 is 4, times 2 again is 8. So similarly, when we say 3 cubed, we mean 3 to the third power, or literally 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. 4 cubed then is 4 to the third power, and it literally means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So be careful with those cubed roots as you're first getting used to them. And just like with perfect squares and square roots, we can also cube negative numbers. So negative 2 cubed, again, it's inside parentheses, means that negative 2 is going to be a factor 3 times. So what's different with cubing a number is now I have negative times negative times negative. So when we squared a number, negative times negative made a positive, but now I'm multiplying that by another negative. So my overall answer is going to be negative. 2 times 2 is 4. 4 times 2 is 8. So negative 2 cubed is negative 8. And when I look at negative 3 cubed, I'm doing negative 3 times negative 3 times negative 3, which is going to give me a negative number and not a negative 6, but a negative 27, because 3 times 3 is 9, 9 times 3 is 27. 3 negative signs gives me a negative overall answer. And finally, negative 4 cubed means negative 4 times negative 4 times negative 4. Multiplying 3 negatives gives me a negative answer. 4 times 4 is 16. 16 times 4 is 64. I think you're getting the hang of it. So on the opposite end then, if a cube root is a number that when used as a factor 3 times, it gives the original number, then I'm doing the same thing I did with square roots, except this time you'll notice my symbol has the little 3 here in the groove to show me that I'm taking the cube root, not the square root. So when I see this, I'm looking for the number that can be multiplied by itself 3 times. So we would think, okay, 3 times 3 is 9, 9 times 3 is 27. Now in this case, positive 3 is the only answer that will work because negative 3 cubed would give me negative 27. So that's one small distinction between square roots and cube roots. So again, when we say 3 cubed is 27, we're starting small and getting bigger. And then when we say the cube root of 27 is 3, we are going full circle, completing that cycle and getting back to where we started. The same is true for negative numbers. So negative 3 cubed is negative 27. And so the cube root of negative 27 is negative 3. So you can see how those work together. Okay, so let's talk about how we solve an equation then. I'm going to do the same thing I did with square roots. I'm just going to use cube roots. So I'm still going to start by solving or by writing the equation. If I want to solve x cubed equals 125, I'll write the equation so that then I can take the cube root of each side. Remembering to use the little number 3 there to indicate a cube root versus a square root. Now a cube root undoes or is the inverse operation of cubing a number, so that simplifies to x, and the cube root of 125 is 5. So again, I'm thinking what number multiplied by itself 3 times equals 125. And you'll find that the more you begin using these, you'll become familiar with these answers and you'll know them right off the top of your head. So in this case, the solution is 5. And if I substitute that back into my original equation, 5 cubed equals 525. Well, 5 cubed literally means 5 times 5 times 5, which is in fact 125. So let's take a second to solve these. If I need to solve, I need the variable by itself, so I need to undo or use inverse operations, get rid of my exponent. So the opposite of cubing a number is to take the cube root. Whatever I do to one side, I have to do to the other. And now I can simplify. The cube root of x cubed is x. And the cube root of x means what number can I multiply by itself 3 times to give me 8? And I am thinking in particular of 2 because 2 times 2 is 4, 4 times 2 is 8. On letter B, we want to take x cubed equals negative 27 and solve that by using my inverse operation, which is to take the cube root of both sides. The cube root of x cubed is x, and the cube root of negative 27. So what one number can I multiply by itself 3 times to give me negative 27? It's negative, so I know I'm going to need a negative answer. And I know that 3 times 3 is 9, 9 times 3 is 27. So my cube root of negative 27 will be negative 3. And let's check these to make sure that we're doing our work correctly. So if I put negative 3 back into my original equation for x, I need to put it in parentheses because I'm going to cube the negative sign with the 3, and I'm going to make sure that that equals negative 27. Well, that literally means I'm doing negative 3 times negative 3 times negative 3, which does in fact come out to negative 27. All right, I will let you work C and D on your own and check your answers here as I work silently. All right, hopefully you found x equals 4 for letter C and x equals negative 5 for letter D. If not, pause and check your work. And I will let you do this your turn question for your quick check. So let's take a look at one more here. If we're going to solve w cubed equals 8 over 343, then let's not be intimidated by the fraction, but let's write out our equation. Off to a rough start. Let's make sure we write it correctly. W cubed equals 8 over 343. Now I can take the cube root of each side. So when I take the cube root, that undoes my exponent of 3, but I literally am taking the cube root of my numerator and the cube root of my denominator. So the cube root of 8 is 2, and the cube root of 343 is 7. So if you're like me, you might be looking at the number 343 and thinking, okay, I have no idea what the cube root is, nor do I have any idea how to find this. So I would just start thinking about the cube roots that I know. We said that 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So then I started thinking about 6 cubed, and I thought, okay, well, 6 times 6 is 36. 36 times 6, that's going to be 216. So then I thought about 7. Okay, 7 times 7 is 49, times another 7, and I noticed that 9 times 7 is 63, so this looked to be a good candidate for our cube root of 343, and it did indeed work out. So you can always do it that way. But let's go ahead and check our solution. So if 2/7 is my answer, let's substitute it back into my original equation. To make sure that it works. So if I put 2/7 in for W and I cube 2, that will give me 8. And if I cube